Addison Stark. You are the founder of Atmos Zero, and you're building an entirely new type of industrial boiler that's never been used or designed before using heat pumps. Get into the nuts and bolts. What are you doing that's never been done before?
It's a great question, and it's something that took me a while to really figure out, hence why we decided to start a company. We looked at what it means to decarbonize industry, or really to think about what is constituting the emissions in industry today. And once you start to look at the industrial segment, you realize, number one, it's very complex. You have a lot of different production processes that make all of the different materials and objects that we use as a modern society. And so the world for a long time was saying, industry is hard to decarbonize. It's going to be something that we're not going to be able to do until, the 2040s, 2050s in a scenario where we're doing mid-century decarbonization. But when you start to actually slice the data, you see, number one, industrial emissions is 3/4 heat, and half of those heat emissions are simply the production of steam, burning fossil fuels to boil water. So we started to ask ourselves, why are we still doing that? And it goes all the way back to 1867 when Babcock and Wilcox packaged the combustion boiler. Really, it was the heart of driving the Industrial Revolution in the 19th century and created the productized form factor of the steam boiler and what we still use today. So we looked at this and said, how do you go in and electrify the boiler in a cost-competitive way? The reality is manufacturers today, when they're choosing to replace a combustion boiler, they're buying electric resistive boilers. Think of an electric tea kettle where you have 1 unit of electricity in, gives you 1 unit of boiling water out. In an electric resistive boiler, that's 1 unit of steam that's going to drive your manufacturing processes. We thought, well, you can do this better, particularly with heat pump technology. Heat pumps are today the fastest growing segment in the building HVAC sector. So today in North America, we're selling more heat pumps for building heat than we are gas furnaces. And this is because of high efficiency and drop-in ease to replace traditional furnace technology.
When you're talking about a kettle and resistive heating, that's really taking pure electricity and putting as much as that energy as you can into raising the temperature of the liquid of water to turn it into steam, whereas a heat pump moves heat around, and that's why it can be more efficient than that simple one-to-one. Is that correct?
That's exactly right. And so that's the heart of the innovation of what we're doing at Atmos Zero, is taking heat pump technology where you are taking heat, moving it, and increasing its temperature. And you can use less electricity to do that. You use the work of the electricity to drive a thermal process rather than simply thermalizing the electricity. So this innovation has allowed for very efficient building heating and is used widely for applications of refrigeration, of air conditioning, and all these other things. But what has not been fully productized up to this point is a packaged steam heat pump that is capable of delivering steam temperatures without a very complex integration in the manufacturing facility. So if you look at the industrial heat pump industry, I like to joke it's been a nascent industry in Europe for 30 years. And that's because largely what you see is a very, as I like to again say, a very French applied physicist approach, where you're maximizing your thermal efficiency in the facility, you're capturing all the waste heat you can, you're optimizing your overall plant thermodynamics. But what you're doing is making a very complex, stick-built, one-off engineering project that cannot simply be copy-pasted to the manufacturing facility next door. So what we decided to do was do what Babcock and Wilcox did with the combustion boiler, to package and productize a heat pump boiler that can be dropped in and replacing combustion boilers as easily as it is today to drop in a resistive boiler. The main challenge today is all heat pump boilers, all steam heat pumps require capturing waste heat at relatively elevated temperatures to be able to achieve steam temperatures. So think 50, 60 Celsius and above to be able to get up to boiling temperatures. That's very complex to capture in the facility, often requires shutting down the manufacturing facility, putting in one-off designed heat exchangers across the facility, running a refrigerant line through the middle of the manufacturing floor. So you need to dig a trench or run it up over through the ceiling. It means you're shut down, you're losing your overall operation time, and losing revenue to be able to do this kind of complex integration. We said, well, what if we do what we do with building heat pumps? Just capture heat from the ambient air that's around us, use the heat pump technology to upgrade that all the way to steam temperatures, and then deliver steam to essentially take a small hit on efficiency, but to drive a huge reduction in capital and to standardize a product and make it so a customer who happens to have 20 manufacturing facilities around the world doesn't have to have a bespoke project in each one to electrify, can just order a spec boiler and deliver it everywhere like they do today with combustion boilers. So the heart of what we do at Atmos Zero is the productization of the heat pump boiler, the standardization, to make it so decarbonization is a product, not a project.
In a bespoke retrofit, how much efficiency is being captured by going out and scavenging that last little bit of process heat versus what you are willing to put aside for simplicity?
Yeah, and it's different facility to facility to answer that question. What is your availability of waste heat? What temperature is it at? Where is it located? So it's a really complex question to answer because some facilities might have 55 Celsius waste heat, which is not that great. Some facilities might have 90 Celsius waste heat, where it might be worthwhile to capture because you do get a sufficient efficiency boost. But for us, it's not the efficiency boost. It's really looking at what is that marginal payback period to do an overhaul to capture that takes into account that incremental increase in overnight capital cost to actually execute that waste heat scavenging project. And we did some analysis of this. And what we found is oftentimes these payback periods will be longer than the asset life of a piece of equipment. Roughly the data, when you look at the Energy Information Agency, EIA, from the US DOE, for implementing waste heat driven units is oftentimes the installation of an industrial heat pump today that requires waste heat generally means let's say you're putting in $1 million worth of CapEx. It's going to cost 5x that for the installation project. So that large incremental increase to capture waste heat is a big challenge for us. What we are seeing is to install one of our units is less than half of the installed capital itself. So that's a big swing when you're talking about projects that could be make or break for a manufacturing facility, particularly those that just don't have the capital budget to be able to justify a 30-year payback period to be able to scavenge a little heat. So, what we really see is for a manufacturer to successfully electrify, it's less about that marginal increase in efficiency. It's about the big reduction in capital to be able to execute on a project.
You kind of answered my question too, which is whatever the efficiency is, it's still probably less in the amortized CapEx to do it the old way versus the way that Atmos Zero is building out. So what does that look like from a product standpoint? I know you guys at the moment have one deployment, correct? Like a test facility. Is it a lot around standardization of sizing and units and being able to say, hey, we've got like 4 units at these BTUs and this is like what we're going to sell versus this bespoke thing? What does it look like from a product standpoint?
So it's a good point, Joel. As all of your listeners will know intuitively, is hardware is hard. What we are doing is focusing on being very capital efficient on the path towards a ruggedized, dependable boiler solution. Because we're not just going into a brand new market, we're going in and competing with the boiler, which has existed for 160 years. There's a lot of track record of success in running a combustion boiler and knowing that, it has an asset life of 20 years, but you're going to find 50-year-old boilers out in industry that are still chugging along. They may not be as efficient as they used to be. They may just be a pain in the neck for the brewers or the cheese makers or whoever's using this, that is just, they know that it's a problem, but we're still going up against something that is tried and true. So for us, we've been focusing on what does it mean to be a product that is acceptable in the manufacturing environment. We are taking and putting together a heat pump with a boiler, which means it has aspects of industrial equipment that people are already used to. The boiler side is really standard. We're essentially replacing the combustor with a heat pump to be able to deliver heat to a heat exchanger that boils water and delivers it to the steam header. But the heat pump is what's novel in the boiler room. But most manufacturing facilities also have a cold chain. They'll have a chiller on site that drives cold or cooling for their processes. And oftentimes this is driven by a vapor compression cycle, the same thing that we're doing. So we essentially see we're marrying together traditional refrigeration technology with steam heat chain technology that is very acceptable and standardized in industry. And that was part of our design philosophy. We wanted to be able to design and implement a product that can be serviced by the same ecosystem around chillers. It is utilizing, our units utilize 95% of the bill of materials comes directly from the industrial HVAC supply chain. We do have in what we do, we have some custom compressor technology that we've designed to be able to enable the very high temperatures we deliver. And that's a big part of our competitive differentiation. But, wherever we could go out into the supply chain and purchase from American manufacturers, European manufacturers, North American manufacturers, we have. Because at the end of the day, what is important is durability and dependability. And by integrating units that are utilizing a lot of tried and true componentry, that has helped us. So we've taken that approach since day one of the company. I think this is actually, to answer your question, allows me to go back to how did we start? When we came up with the concept of what we wanted to do here, we recognized that we wanted to not start down the road of a lot of hardware companies that start with a small benchtop prototype, then simultaneously have to deal both with scale up challenges, but also scale out challenges. We wanted to start right away at a relevant industrial product size. So we spun in to Colorado State University. I'm currently sitting in Fort Collins, Colorado, where we're at CSU. I'm actually sitting at their Energy Institute, where we did our first prototype testing, which is a former coal power plant that was turned into an industrial research facility. It's outstanding. As an MIT grad, I like to always joke, when I'm around there, that I couldn't build this company in Cambridge. I had to go out to the middle of America where I could find an interconnect big enough to build large-scale industrial facilities and find graduate students who show up knowing how to weld, people who learn to weld when they're 10 years old on the farm, farmers with degrees, people who were diesel mechanics before they became mechanical engineers, people with a hands-on intuition that it's hard to find at the coastal universities. But we started here and we recognized we needed to go straight to industrial scale. So the first prototype we built is a 1 ton an hour steam boiler, which is a standard product size. That's 1 ton of steam per hour at 4 bar. So 150 Celsius. That's a 650 kilowatt thermal unit. That's about the size of the room I'm sitting in now. Not a small piece of equipment, but what that allowed us to do was start to test and develop on the relevant scales. So we didn't have to run into those scale up challenges that are very difficult in thermal systems, in reactive systems, in rotating and mechanical systems. We were starting with the main compressor componentry, heat exchangers at the relevant scale. So
what does a 1 ton an hour boiler at that scale, like what kind of industries use a boiler at that scale? Like who are your targets?
yeah, for sure. So our first pilot that we're doing, that we've done one more revision from, is also a 1 ton an hour boiler that we're bringing over to New Belgium Brewing here in Fort Collins. Our neighbors as I like to think about it, is we've been running a healthy beer tab with them. Now we owe them some steam, but it's just a 15-minute walk from where I'm sitting today is their flagship brewery, where we're going to be dropping in a 1 ton an hour steam boiler. That's going to replace 1/3 of their steam demand. So they have 4 boilers on site. They run N+1 redundancy. We'll be replacing 1/3 with this. 650 kilowatts thermal is a pretty standard size for a lot of industry. 65% of manufacturing facilities have a thermal load below 10 megawatts. So really the majority of manufacturing is serviced as this light and medium duty industry. So think like large craft brewers, think bakeries, think laundry, think biochemicals, cosmetics, food processing, things that are distributed around agriculture. These things often have smaller loads like this that need to be serviced by something at the 1 megawatt scale, the 1 ton scale, up to maybe 10 tons.
You just answered my question. I was going to ask kind of what the threshold is before you would start moving 1 ton units in series or whatever until you go up to a larger boiler. But my other question is this: New Belgium, makers of Fat Tire, a very good beer. Are they? They're a business. They don't really have any immediate incentive to try something new. How did you end up getting connected with them? What's their appetite for trying new types of tech?
Yeah, New Belgium has always been an innovator in the brewing scene in North America. They've always had they're a Colorado company, right? They're very conscious about the environment and have seen that as a differentiator for their brand. But also as a consumer facing company, they see that as being a very real marketing differentiation for them. At the end of the day, when you look at a fermentation driven process like brewing, you could also look at things that also involve brewing and distillation, liquor, or you can look at cosmetics, biochemicals, anything that has kind of a biological process. The production and utilization of steam is one of the largest on site emissions drivers that they have. So if you look at brewing, about 50% of emissions is coming from the fermentation of the grain and the yeast releasing CO2. The other 50% is coming from boilers. So it's one of the highest leverage opportunities for decreasing emissions in that industry. So we were connected because CSU and New Belgium are two of the biggest brands and employers and drivers of economic activity here in Northern Colorado. And they were looking for a technology to help them to electrify. And we were able to come in and start to scope out and partner with them. One of the things about being an early stage startup is you've got to find partners, not just customers, people who are along with you and recognize they're playing an integral part of bringing a new technology to the market. And what they really saw was there's no other viable economic path to electrify or decarbonize their steam fully. And it really took a paradigm shift like what we're doing to be able to offer them a solution. Otherwise, they really had no path, economical path forward.
How did you get into this though? Because your background is not starting a bunch of hardware and certainly industrial scale companies. You have a background in policy. You obviously went to MIT. Where did this all come from? How did you become I want to solve big problems thinker?
You're exactly right. And I think the way that I first start to say that is I never had the desire to be a startup CEO founder, but I came up with an idea and I thought of a product, and I knew that the way to get this thing truly developed and commercialized required some sort of an approach like this, that we weren't going to be able to get a large industrial HVAC company or boiler company to do this without having a startup go out and prove the path forward. So yeah, I mean, you're right. I've had a circuitous professional life, and I like it that way. I like focusing on big lever impact and just going after it. And so I grew up on a farm in eastern Iowa, the son of a farmer, railroad worker. Really, I like to think of my dad as an engineer without a degree, like most farmers. You just know how to build and fix and do, and you're very hands-on.
Farming is mostly small engine repair. What kind of farm was it? What did you guys raise?
It was a stock farm, so we had stock cattle that we sold to feeder lots. We had rental ground. It was small, 100 acres. My dad also worked full time for the Union Pacific Railroad, but it kept us busy, that's for sure. But it really kind of showed me, and exposed me to the overall kind of economic activity in the Midwest. I saw kind of, simultaneously the impact of climate change in farms. It kind of drove me towards these broader, bigger issues. But also saw, and I still think back to the city where I grew up near, Clinton, Iowa, being kind of a Rust Belt town on the Mississippi, and the decline of industry. It's one of the big things that actually is part of what's driving me right now and building in a new American manufacturing company. But it was that draw to work on big problems brought me to the University of Iowa and then off to MIT, where I studied mechanical engineering, stayed for my PhD. Actually worked on combustion while I was there. So, there's a little bit of irony in now that I'm working on a core technology to decrease combustion. But that led me to where I really started to work on innovation, and early stage innovation was I went to ARPA-E, U.S. Department of Energy's Advanced Research Project Agency for Energy, where I like to think is like America's best pre-seed fund for climate tech, hard tech, innovation, high risk, high reward investment with no expectation of returns. Really allowed me to see innovation at the cutting edge of manufacturing efficiency, chemical engineering innovations, the innovations in thermal systems. And it allowed me to also build a large network across the country where I saw places where this innovation was happening. It was actually getting close to about 10 years ago that I flew to Colorado and visited Fort Collins, visited CSU for the first time, and met my co-founder and CTO, Todd Bandauer, because I was managing a project that funded some work he was doing that was a waste heat-driven chiller system for decreasing water consumption and power generation. We saw that as an opportunity to drive innovation in thermal systems, which really hadn't been innovated in for 50 years. And thinking about how could we leverage advanced systems design, advanced manufacturing, and apply it to the heat exchanger. So got to know Todd at the time and saw an ecosystem, an innovation ecosystem away from the coasts that had massive potential for growing a manufacturing company.
Your time at ARPA-E, I bet you also saw a bunch of really novel solutions to things that weren't able to be commercialized. Of course, that information or that experience is useful to you now, but was there any trend line or common set of experiences that you saw that people that did have a solution weren't able to stand it up at scale?
I think over the past decade, we've come a long way in the hardware space to be able to build the capital models, the support structures, and the institutions to support entrepreneurship in the space that did not exist a decade ago. I think part of it is institutions and investors like the DOE taking that kind of risk, particularly ARPA-E. But then you look at some of these other institutions like Activate or Cyclotron Road or these other kind of early stage scientific support structures that are being created for innovators in deep tech science hardware that help to actually translate from the lab to innovation. you know you're right that there are a lot of showstoppers along the way. um Usually we've all been pretty good about finding the first ones, which is the first and second law of thermodynamics. There's a lot of ideas that should stop right when people propose them. But then the next parts get harder, right? Once you move beyond fundamental physics, is what are the engineering challenges of scale up that you may not see today, even if it's physically viable? But it's really driven by the techno-economic analysis. Where do you get to the point that what you're trying to do is not economically viable from a base of, thinking about the capital requirements, the OpEx, the maintenance costs of actually implementing a new tech. None of that was very intuitive about what was funded by government for multiple decades I think that we've matured very quickly as we think about the line towards commercialization of tech, but also it's been the maturation of the markets themselves. 10 years ago, I don't think there was much interest or appetite for electrified steam solutions like there are now. There's various reasons for that, right? I mean, there's broader corporate goals for decarbonization. There's also the requirement for being able to, compete in a global market where there are requirements to decarbonize, particularly if you're exporting into Europe or if you're thinking about meeting that. But then also there are manufacturers that are in geopolitical constraint. So manufacturers in Western Europe where you're no longer have access to pipeline natural gas, you're using imported LNG from the US or other global markets, but prices have gone up and electrification represents supply chain redundancy, resiliency, and security to keep your manufacturing up and running. I've been thinking a lot recently about this idea of American energy dominance and what does it mean for us as manufacturers in the US. And, one of the things that I see is an opportunity for us to think more ambitiously about the definition of American energy dominance. That right now, the framing coming from the Trump administration is that, we should be exporting LNG and oil and maintaining this global dominance, which we already are, which is great. But I think the ambition can be larger because there's a two-pronged approach that can be here is also the world is demanding the technologies that are driving this energy transition that's already underway. I think there's an opportunity that we could miss as America if we don't actually work very diligently as manufacturers, as a country to invest in being not just the innovators of these new tech, which is great, right? We've innovated a new boiler solution, but I also would love to see us manufacturing it here in the US and exporting it to global markets, these boilers, the Boiler 2.0 itself, rather than being forced to have to manufacture this outside of the US for global consumption, whether it be through contract manufacturer or being forced to go outside of US territory to export without threat of tariff. I think that there are some of these challenges that, you know, US manufacturers might be seeing on the horizon that is driving uncertainty right now. But I see we could do a simple reframing, which is a great opportunity.
LNG, shale, fracking boom that was pretty unexpected 20 years ago. There's a lot of similarities that I see that the U.S. has right now to what Saudi Arabia went through over the last 50 or 60 years, which is right now we can kind of have the best of both worlds. We can be a net exporter of fossil fuels and use that to kick up American manufacturing, kick up American innovation, and if and when those supplies start to dwindle or global prices make it so that it's not as profitable for us, we have another product to go ahead and export. What are your feelings on, energy dominance geopolitically? Like, I think in the broadest strokes, everybody understands that if you control your own energy supply, that's good. If you have an excess energy supply, then you can sell it on the export market, and that's even better. But it seems like a lot of times that's where the thinking stops. But there's got to be more nuance to it, especially on the innovation and supply side. Where could we as a country be investing today to put us in a better geopolitical position 10 years from now?
I think that that's exactly the right thread of thinking we should be going down. The way that I think about this is it is great that we are currently, geopolitically powerful because we are exporting and as a net exporter of fossil fuels. However, I think that the folly that many people make is to think of fossil fuels simply for their energy component. You know, Fossil fuels are a wonderfully complex mixture of chemicals and materials that actually have much higher value when they're being used as an input into manufacturing, into making plastics, into making advanced materials, carbon fiber, than they do simply to be burnt to boil water. I think that that's the lowest common denominator use of our natural resources. Then thinking about decoupling energy from materials. So, yes, there is a tremendous value in a highly power energy dense liquid fuels, but we also see that electricity is quickly overtaking on an economic basis against petroleum in transportation. But that just means petroleum now can be repurposed for other things like advanced material manufacturing. I think that simply exporting for burning in global markets is good today, but it's not just how do we prepare for the next part of the transition and make sure we have something to switch to. Like you're right, Saudi Arabia is desperately looking for diversification in their industry because they've just been dependent on being a petro state for so long. I think, given the differentiation of who we are as Americans, is we have the opportunity to innovate and think bigger than just burning fossil fuels. I think that's the transition that we have to think through about taking advantage of these resources to drive much higher value creation and the direct utilization of electricity that comes from solar, from wind, from renewables, from nuclear, whatever it is on the grid as the grid decarbonizes should be used for its energy potential, absolutely. And we should think differently about the materials we have from our other natural resources of fossil fuels in the ground.
When you're trying to model out, and again, knowing it's early days, when you're trying to model out what Atmos Zero will be able to do from a sales standpoint, my understanding, and correct me because I'm almost certainly wrong, is that a lot of American manufacturing that could be your customer base are pretty OpEx, CapEx, finance limited, and are just kind of eking through. To go back to an example that you used, a lot of these boiler life cycles are 20 years, but maybe they're 50 or 60 years old because they're still going through. How are you able to model out what you think your customer base will be, knowing that they are finance limited and a lot of times when it comes to improvements?
I mean, that's absolutely the case. And when you think about capital investment in a manufacturing facility, oftentimes uh, the utilities, the boiler room, the steam system, the power generation is not first and foremost. You want to invest in your top line, not your bottom line when you're doing capital deployment. The choice between a new fermenter and a new boiler, everyone wants to put the new fermenter in because that's increasing your capacity of manufacturing, right? So there is a lot of dynamic that goes into how customers make decisions in this space. So that's why, part of our framing is on this productization. It goes back to some of the drivers of what we think about. Well, capital constraint is very real and oftentimes is the make or break of saying yes on a project. And so our focus as being us as a company, we are a manufacturer. We are an OEM manufacturer of this boiler. We are focused on COGS reduction. We are focused on packaging of decreasing logistics, shipping costs to be able to bring this to the customer, being able to partner with preferred EPCs, steam contractors that we can focus on the minimization of installation costs, the ease of installation for the whole thing, and doing what we do best, which is an innovator and a manufacturer. But there's a lot of innovation in the industrial decarbonization, the industrial electrification space. There are other companies around us. I wouldn't fully say competitors. I would say other people in our ecosystem that are innovating on things like heat as a service. So bringing in a third party financier to pay for that equipment, where they can own and operate it, and then simply deliver steam as an OpEx and make it so no CapEx is being spent by the customer. That allows for a different financialization, or some customers actually prefer to own and operate, depreciate their own equipment, and do an asset sale from us. So I think that it's not clear exactly the path that will help to drive this, but what we know is it's going to require not just technology innovation, there's also finance and capital and business model innovations and continued evolution of policy. One of the things we, as a pragmatic company looking to scale, we do is focus on bringing this technology to customers where it clearly pencils today. That's places where the customer is exposed to either high gas prices, so think where you're dependent on LNG, but you have relatively cheap electricity, or places where you have supply chain risks in general to gas, where there's this other added value of maintaining and keeping uptime going by having fuel flexibility. Um, but then also partnering with these third-party um, energy as a service companies who could deploy our unit, own and operate it, and then offer these different financing solutions to the end user.
I want to ask you about US manufacturing as you're looking forward to large scale production of your boilers. But first, I'm going to give you a math trick. If I had a 1 ton Atmos Zero boiler and I wanted a square footage of solar that it would take in current solar panels to actually run that boiler, what am I looking at? A couple acres? Like, what would it take for me to give me in my factory the optionality to say, if the mains power shut off tomorrow, I could run this on solar?
My deepest shame as a MIT engineer is I'm no good at mental math.
Oh no.
And yeah, so what I'll tell you, Joel, generally, for the thermal load of any manufacturing facility is oftentimes you do not have sufficient on-site square footage to be able to generate the necessary power to be able to deliver the thermal load, even with a high efficiency solution like a heat pump. So that's a big part of no matter what, you're going to see manufacturers having to be tied into the grid and then utilizing generation elsewhere. So I think it's very difficult to imagine completely off-grid manufacturing, but you're right. It's measured not in a few hundred square feet. It's measured in much larger areas.
Whatever it takes to make a megawatt, I guess, if that's like
Correct.
the
Yeah.
average
So,
draw.
I mean, if our heat, it would require less. So if you're delivering 1 ton of steam, that's 650 kilowatts thermal. Our unit can do up to about a COP of 2, meaning that it'll require half that electricity. So you're talking about 320, maybe on the coldest days, 400 kilowatts of electricity. So, people at home can do the math depending on how efficient they assume their modules are, where they're sitting relative to the azimuthal angle of the sun. What is the real requirement? But it varies seasonally, right? So the grid is going to continue to play an important role for balancing electricity for an electrified manufacturing facility.
I would imagine as you're penciling out your go-to-market at scale and looking at American partners for manufacturing, that there are some areas where you think it's a clear uh, success, both in possibility and price, and somewhere you're like, we just don't build that in the 50 states. We're going to have to go outside of the U.S. to supply that. Are there any red flags that you're like looking at where you're saying we would have a dependency external to the U.S. to be able to complete our supply chain?
You're getting into a very complex issue, right? And I think it's the thing that, again, the listenership as this podcast builds, we are all thinking about this. Like, there's a reason you want to build a manufacturing company in the US. A lot of us grew up around it. We grew up with parents that worked in it. We recognize what it did to build the middle class that enabled people like me to go off and, become an innovator instead of going straight to the plant. It's also what's driven the challenge in US manufacturing. We see an opportunity to build a high value product in America for certainly the North America market. But then the question starts to go, when does the logistical cost of shipping into other global markets become more expensive? Or, when do you start to run to the point where the biggest levers you can pull to reduce COGS of these units starts to be labor costs or overall supply chain costs to get everything into the US. These things are highly uncertain right now. I think, as you and I are recording, it's every day is a little different on what the tariff landscape looks like. And this just adds a layer of uncertainty to building manufacturing in the US. we see the long game, that we think things will level out and there's going to be an opportunity to think through, right sizing any sort of import export tariffs to be able to make it so manufacturing can thrive here. But we do have a heavily US based supply chain today. However, there's the embedded supply chain inside of US manufactured components. Where did the raw materials come? How many times did they cross the border? That we don't have the real answer to today. Obviously, I have the ambition to build an American manufacturing company here. I think we will always have an American manufacturing presence, particularly for the American market. But as we grow to global scale, it is important to think about regional manufacturing for deployment in Southeast Asia. It doesn't make sense to build and manufacture in Colorado, send to the port, ship, or is there going to be better ways to deploy and continue to reap the benefit to a US manufacturing company from that, whether it be through partnerships or building manufacturing in other regions. But today, this decade, in the 2025 to 2030 window, we're a company squarely focused on building manufacturing in America.
There will come a day, hopefully, with Tool or Die that I will be a lot more strident with all of our guests and be like, what is it taking to get that last 1% in the US? You get to a good point now, though, which is just the political climate and the infrastructure climate, which is, we were talking to Russell Verone, another factory builder and engineer a few days ago, friend of the show, and he was making the point that manufacturing, his point was that manufacturing can sort of look past politics because the time scales for standing up a factory or delivering a product are, past 4 years, often past 8 years. But I think there's the flip side of that same argument, which is it's really hard to make long-term investment in the U.S. From a manufacturing standpoint without the certainties of maybe there's going to be a tariff on the one thing that we don't have a bauxite mine supply in place for. And it's not in a market economy realistic to expect every new innovator to also own their complete stack all the way back to the raw materials. So that's just putting an asterisk next to that. That is something that is going to have to continue to evolve. The other part, though, then the reason that I'm asking this question of almost everybody now is, we have already some listeners who run machine shops, right? And with 10 or 20 people in a job shop. And I always like to ask everybody on that side, too, because of where I do think some of the initial investment and opportunity is in that scale for in the U.S., either in existing shops or standing up new ones to say, hey, we really need somebody great at extruding aluminum and we can't get that supply, but we've got the demand. Are there any things like that? And again, early days, I'm not trying to put you on the spot, but are there any things like that where you're looking at saying, seems a little weak here, but these seem like easily solved supply chain problems?
I mean, yeah, again, you bring up a bunch of super interesting and important things to talk about, and I kind of want to touch on a couple of them. Number one, I think, as we're talking around politics right now, I think it's worth even talking about, like, I'm concerned that we run the risk of reindustrialization becoming unnecessarily politicized, brought too far to a conservative bend, or being dominated by a union-focused bend from the left. The reality is a lot of us grew up around industry that it was just part of the economic fabric of America. And I think this politicization is a risk right now. The way that I think about it is like, this shouldn't have that layer. Like, there's risks from political risks are something that I think is actually real. I want to push back against this point that we can look beyond politics because timescales are long. This is true, but capital doesn't look past political swings. And to be able to actually rebuild the manufacturing base here, capital needs to be able to be deployed in a timescale relevant as well. And when your customer base also is going to be exposed to tariffs, they might suddenly be deciding, well, maybe actually we don't want to expand manufacturing in the US right now. So then our unit does not get deployed to a manufacturer here. Just as a hypothetical, we don't see that yet. But it's something that, I think there's a lot of dependencies here for each layer of the manufacturing supply chain that are dependent on each other, both in the US, but ultimately somebody is trying to export. And if we start to see retaliatory tariffs and their equipment type falls under that tariff, they could lose a whole bunch of export business that cascades upwards. And from upstream, the people that are trying to import raw materials running into that challenge as well. So I think that there is a lot there that we're just going to have to see how it plays out. But I don't think many of the nascent startups in this space right now, the innovators that are trying to take advantage of the baseline machine shops that exist, we want to be able to partner with them. The question is, will our venture investors be there in the future if they just see uncertainty in the U.S. Political and economic ecosystem? So that's one thing. But also, yes, you're exactly right that as we have focused on building up an American manufacturing presence here, as we have enjoyed the process of partnering with established machine shops, job shops here in Northern Colorado. One of the nice things about here is it is a oil and gas region. So there's a lot of small and medium, specialized manufacturers, welders here that you wouldn't find in other regions that we've been able to take advantage of, that, they are happy to partner with us. As the oil and gas job shops around here like to joke, they need something to fill the counter-cyclical nature, and they love us greenies to be able to, partner with us when the oil work is down. But, the reality is a welding job on a pressure vessel is a welding job on a pressure vessel for these guys. And they have the specialization and skill set that allows them to play important roles in an energy transition framework where they know how to be able to support both industries. When we start to think about things like precision machining, one of the things that us as an HVAC manufacturer, we use we design and build our own compressors, which require very high precision machining of the aerodynamics of the compressor components itself. In Colorado, we've been able to take advantage of the fact that there is a huge aerospace presence here, but also the growth of that industry in the US has helped to grow really high quality precision manufacturing shops around the country. That has allowed us to be able to take some of the innovation there and apply it to what we do. And so I think a lot of that knowledge lives in these shops, and the opportunity to take advantage of that and be part of their growth, reinvigoration and growth has been very exciting for us as well.
You bring up a good point without going through our 95 theses about why we believe so much in reindustrialization. It's inarguable that we think it's a net good. That's why we're doing Tool or Die. That's why we're taking this stand. But it's also arguable that it needs to look like it did in the 19th and 20th century. There were problems in how we did industrialization before, from the fact that I can't eat fish in my closest big river to labor problems. And I lean leftist and pro-union, but it's not like unions weren't impediments in many situations as well. So I think you bring up a good point there. It's like you can't ignore the politics. There can be part of it that transcends politics, because there are some outputs of bringing this back in. The most ineffable of which, but in a way I defend the most, which is just pure pride. The ability for a nation to be able to say, we can do this too, should we choose to do it. Your pilot program with Atmos Zero and New Belgium is going great. Obviously, the company is getting stood up. You see a ton of opportunity in the steam and the boiler sector, but you also come from the ARPA-E side and the experience. You have a great 10,000-foot view on where some of the opportunity space is. In energy and efficiency and decarbonization, are there other places that you were looking before you said, steam boilers, that's my passion, that's where I'm going to go? Are there other places that you think other innovators should be looking within the supply chain and the energy sector to be able to say, we don't need to fix everything, but there's a big value in improving this one piece?
Yes, is the short answer. I think about high leverage opportunities all the time, and that's what brought me to steam. But when I, kind of re-peel the onion that I unpeeled before, I guess, put the peels back on. That's a bad analogy, but I'm going with it. Is, going back and think about heat more broadly. I think is still a great space. 3/4 of industrial emissions, right? We're focused on one aspect of it, one working fluid, but what is the productized form of replacing the blast furnace? There's direct electrification that's going on in steel. You look at incredible companies like Boston Metal. You look at other people that are trying to use hydrogen or, things as a way to go in and decarbonize that. That's an incredible space for innovation. You look at cement. These things are super exciting. It's not new for people to run into because there are other great companies working on it, but it hasn't been solved yet. And then when you think beyond that, you have to start thinking about how do we actually enable reindustrialization in the U.S. I'm so heartened by the activity when you pay attention to what's going on Twitter about around the reindustrialization movement of rethinking the job shop, rethinking, automation, thinking about how do we actually do high value manufacturing cost competitively here in the US again through, a lot of layers of innovation. I'm excited about that. And how do we plug into that supply chain as a downstream assembler of products? How do we, take advantage of that to drive down the cost of our supply chain and components and, keep an American supply chain as we drive continued cost reduction? There's so much innovation in that space that I think is ripe. Um, the broader opportunity, though, is we go back to earlier in this conversation, is for our unit while deployed out in the field has to be taking in clean electricity, and driving the continued reduction of emissions on the grid is a huge and continued opportunity that's being driven by innovation in renewables, but also when we think about things like advanced geothermal, fission, and even, maybe before I die, a fusion reactor on the grid. These things are all tremendously ambitious and exciting. And, the way I like to think about things is reindustrialization calls for industrialists. I like to think about myself as a clean industrialist. I'm excited about innovating in something that has been truly the forgotten room in the back of manufacturing facilities, but gives a scalable opportunity. And if I get to become, the head of the next great American boiler company, that will be a tremendous thing to look back on in my life. And I'm just excited about the opportunity to do something at the scale of American industry. I think it's probably what draws a lot of us to this.
I think a lot of people are feeling that right now that come from the academy who are just trying to see some stuff happen. I think that's also been a big move or a cultural zeitgeist thing. It feels like we've been stuck for a while, and I think that's causing a lot of people, Americans especially, to say, how do we do things now? It's been so great having you on. We have one quick lightning round, and then I will let you get back to it. 3 questions. The first, as an Iowan, you can annex one state to add to Iowa. Is it Missouri or Nebraska?
Oh, I'm a Midwest purist, and I believe it's generally Eastern Iowa, Southeast Minnesota, Southern Wisconsin, and Northern Illinois. Anything beyond that is not Midwest. So I would have to go with Missouri because of just, ever since Nebraska joined the Big Ten, there's a whole new forced rivalry upon me, and I just can't accept them in. They're still Big 12 country out there.
There's no right or wrong answer when it comes to imperialism, so I will accept that answer. The second question, what are your best sources that you would give to other people in the industry to stay up to speed on manufacturing and energy news, especially stuff that's not a mainstream outlet? Like what are some journals or places behind the scene that you would encourage people to read?
Yeah, that's a good question. I love the society magazines, ASME magazine, Mechanical Engineering, AICHE Journal. One of the things that I am a proponent of is ASME was created because boilers were blowing up. It was the American Society of Manufacturing Engineers, mechanical engineers, came together to start to build and create safety codes around boilers to help to make the industrial environment safer. And that's what led to the modern ASME society, and I think is super important. So I like to keep true to being a mechanical engineer and reading that.
All right, last question. Your favorite New Belgium beer, and you can't say Fat Tire.
The thing about being in Fort Collins is I'm actually where they have what they call their fodder forest. They have a collection of dozens of large barrels from Belgium that they do long fermentations, long agings here. So they have a really sophisticated, rotating, complex Belgian style sours, other sorts of things that they do here. And the thing that I really like over there just showing up and seeing what's fresh and what's new out of the barrel. One thing that you can buy that you can probably get outside of Colorado is I really like their orange triple. They have a Belgian triple style that they put a little bit of orange in. It's one of my go-tos at home on a on a cold winter's night.
I love it. Addison, thank you so much for coming on Tool or Die. We will talk soon, and I wish you the best of luck. You got a long road ahead of you.
Thank you very much, Joel. This was outstanding. And, if you ever need a boiler, give me a call.
I'm going to have the hottest house in Westchester County. It's going to be great.